Hello, we're going to take a look at one-step equations that can be solved using multiplication and division. Okay, here we have a balance, a scale, a seesaw, whatever way you want to look at it, and this side is equivalent to this side. They're equal. The fulcrum's in the middle, and remember that the fulcrum represents the equal sign. So this is our fulcrum, which is our equal sign, saying that this side and this side are balanced. Okay? Over here we have our rectangular algebra tiles, which are our variables. Okay? Well, we have three of them. So what equation would this balance model? It models three variables, which would be like 3m equals, and these are all negative chips, and there are 2, 4, 6, 8, 10, 12. Negative 12. Okay, now 3m equals negative 12 is the equation that matches what I see right here on my algebra mat. So now I'm gonna solve this. How do I figure out 3m equals negative 12? Well, 3m, being that the variable is right next to a number, means 3 times m. Just like if it were 3 next to an 8. That would mean multiply. 3 times 8 would be 24. Well, in this case, we have 3m, and what number times 3 would give us a negative 12 is what we're looking for. Well, to solve that on our algebra mat, I'm going to take these three variables, and I'm going to split them. So I have 1, 2, 3. Okay, I'm splitting them apart. I'm going to split these chips also apart into 3 groups, and I'm going to match them with each one of these variables over here. So if I split these 12 into 3 equal groups, I would have 1, 2, 3, 4. 1, 2, 3, 4, and then 4 in that group. So m equals 4. And all I did was divide. Well, the inverse operation of multiplication is division. So I'm going to use the opposite operation of multiplying, which is what 3m is, multiplication, and I'm going to divide 3 divided by 3, which gives me just m, and I'm going to divide whatever I do to one side, I have to do to the other. If I split this into groups, I have to split this into groups. So I'm going to divide over here by 3, and that gives me negative 4. So m equals negative 4, and I can see that that's modeled here on my algebra mat. Let's go over here and take a look at what's modeled on this mat. Okay, over here on this side, I have my variable, and over here I have my whole number here. And I have 1, 2, 3, 4, 5, 6, 7, 8. 8 negatives equals, the fulcrum means equal, and then on this side I have 2 variables. I can call my variable r this time. So 2r equals negative 8, or negative 8 equals 2r. Okay, it's the same. So I have my rectangular algebra tiles that represent my variable, and I split them apart, and I'm going to split up my red tiles over here to represent the whole number, negative 8, split into 2 groups. Now, 2r is multiplication, and the inverse operation of multiplication is division. So I'm going to divide by 2 to get king variable alone and to cancel out the 2. And whatever I do to one side, I do to the other side. So negative 8 divided by 2 is going to give me a negative 4. Okay, let's see. I'm going to divide this by 2. So I split that into 2 groups. And then I'm going to split this into 2 groups. And I can look and see that r equals a negative 4 here on my algebra mat. And up here, r equals negative 4. If I plug negative 4 in for r, negative 4 times 2 is negative 8. We use the multiplication property of equality when we're trying to solve an equation that contains division. The inverse operation of division is multiplication. So we're going to multiply both sides of an equation by the same number to produce an equivalent equation. So multiplying both sides of an equation by the same number will produce an equivalent equation. For example, if A equals B, then A times C will equal B times C. So down here we have x divided by 3 equals negative 6. So we're going to use the multiplication property of equality. So x divided by 3, the inverse operation of division is multiplication. So I'm going to use the inverse operation to solve this. I'm going to multiply 3, or 3 over 1 is the same thing, times x over 3. Well, the 3's are going to cancel out, and I'm just left with x over 1, or just x by itself. Now, keep in mind, whatever I do to this side, I have to do to this side to keep it equal. Just like this says, A times C equals B times C, if they're equivalent. So since I multiplied this on the left side by 3, I have to multiply the right side by 3. And I get negative 18. So x equals negative 18. Now let's plug it in, check it, and see if it works. Negative 18 divided by 3 equals a negative 6. And so it's true. We also will use the division property of equality. The division property of equality says that dividing each side of an equation by the same number produces an equivalent equation. So, for example, if A equals B, then dividing A by C and dividing B by C will keep my equation equivalent. Let's take a look at this example. 18 equals negative 4y. So I'm trying to figure out what y is. And if they're equivalent, whatever I do on this side, if I do it on that side, my equation will stay equivalent. So over here I have negative 4y. Now this is multiplication. And the inverse operation of multiplication is division. So I'm going to divide the right side of my equation, the right side, by negative 4. So negative 4 divided by a negative 4 is just 1, or just y. 1y is the same as just y. And I'm going to do the same to this side. 18 divided by a negative 4 is going to give me a positive divided by a negative is a negative. And I'm going to end up with 4 goes into 18 4 times with 2 left over out of 4, which is the same as negative 4 and 1/2. And then I have y left on the right. So y equals negative 4.5. Now if I plug in negative 4.5 for y, a negative times a negative is a positive. 4 times 4 is 16. A half times 4 is 2. 16 and 2 is 18. So that works. Let's try out those properties. Let's look here where we have x divided by 5 equals a negative 2. Okay, what property are we going to use here? We are going to use the multiplication property of equality. So x divided by 5, the inverse of division is multiplication. So we're going to multiply both sides by 5 times 5 times 5. And when we do that, we get, remember, if I multiply this side by 5, 5 over 1 is, which is equivalent to 5. My numerator and my denominator are going to cancel out because 5/5 is just a whole. And then I have x over 1, or just x left. So x equals negative 2 times 5 is negative 10. So x equals negative 10. If I plug negative 10 for x, I get negative 10 divided by 5 equals a negative 2, and it works. Number 2, negative a equals negative 24. Okay, negative a. That is always when you have a variable by itself, it's the same as 1a, 1b, 1c, whatever the variable is. It's the same as if there's an invisible 1 right there in front of it. I'm going to add that 1 to the front of it. So negative 1a equals negative 24. Well, what times 1 would give me 24? Of course, it's 24. We can see that. But let's use the division property of equality to solve this one. Negative 1a, this would be multiplication, 1 times a. The inverse of multiplication is division, so I'm going to divide, I'm going to divide by negative 1. Negative 1 divided by negative 1 is just 1, or just a by itself now. So I have a on this side, and whatever I do to the left, I have to do to the right. So I'm going to divide by a negative 1. Negative 24 divided by a negative 1 is just 24. So a equals 24. And if I plug 24 in for a, then it works. I have negative 24 equals negative 24. Number 3. 3 equals negative 1.5 n. N, my variable, is on the right side. So I'm going to start on the same side where my variable is. On the left, I have the 3. I want to get my variable alone. Negative 1.5 n is multiplication. That's like 1.5 times n. And so what's the inverse of multiplication? Division. So I'm going to divide by negative 1.5, which that's just going to cancel out and give me 1 n, or just n. And if I divide 3 by negative 1.5, I know I'm going to get 2. It's a negative 2 because it's a positive divided by a negative equals a negative. So negative 2 equals n. Now if I plug in negative 2 for n, I get negative 1.5 times negative 2. A negative times a negative is a positive. 2 times 5 is 10. 2 times 1 is 2, plus 1 more is 3. And I bring my decimal. There's one decimal spot, and I bring it over, and I get a positive 3.